All right, sweet deal. All right. Okay, guys, my objective today is to really kind of just show you how when we're talking about things growing exponentially, there's really two types of equations that you need to memorize. They're very similar, so it's not very difficult to memorize. But outside of that, every other equation, it's like a variation of those two, okay? Really just one of them has variety to it. So one is that the future value equals your present value, what you have now, times e to the rt, okay? And this e right there, it's another irrational number that you haven't seen yet. There's one other irrational number that you should be very familiar with because you took geometry last year, which is pi, right? And pi is the irrational number dealing with circles. Okay, it's talking about the ratio of how many times that the radius of a circle goes into that circumference, right? So you got 2 pi r. So E is the number that is talking about continuous growth, and E is approximately 2.718, but just like pi, it goes on forever. So pi is not just 3.14. It's not 3.141, right? It goes on forever. So does E. And E, though, is talking about continuous growth, all right? So kind of an interesting example, population growth is continuous. So, for example, how many times does a population compound on itself in a year? And this is just kind of a random example, but it's kind of weird to think, how many times does a population multiply with itself in a year? And you don't really answer that question, right? If there was any answer, you don't say a population compounds with itself twice a year. Or you don't say a population compounds with itself 4 times a year. Does that make sense, what I'm saying? So the only thing that might make a little bit of sense is like a population compounds maybe every 9 months. And you can think of where I'm getting that number from, right? How long it takes a baby to be born. That might make some sense. But we use things like anything in nature that grows, like the growth of a flower. You know how it's continuous? It's not like it compounds 4 times in a year. So, for example, it stores up all of its growth in January, February, and then in March all of a sudden it goes poof, and grows like that. You know? It doesn't do that. It's continuous and it's steady, just like population. That's how things in nature grow, okay? That's what the letter E is dealing with. So when it says something is growing continuously, you're going to be using PERT, P-E to the RT, okay? The other equation is, notice, you have a future value and a present value, but this one is just 1 plus the rate to the t, okay? And there's variations of this. Sometimes, this is typically in the context of like you buy a piece of art, and that art accumulates value, right, at a rate of 10% a year. How much value is that piece of art going to be in 10 years? But you see how I said 10% every year? What if I said it accumulates interest, but that interest is compounded, 4 times a year? Okay, and this is what it means to be compounding. So sometimes when you compound interest, you divide it by n, because it's not just the rate. You don't get the rate that 10% interest 4 times a year. You get a fourth of that 10% interest. Does that make sense? And then you also have an n up here. So t times n. And usually they write it in this order. N times t. All right, so let me show you an example of why that equation, this one that I just wrote up here, and this equation, F equals P times 1 plus R to the T, are the exact same equation. All right? And they'll teach it to you as 2 separate equations, but I'm saying stop memorizing the equations and actually understand it. They're not 2 separate equations. This is just when it compounds once a year, compounded annually. So if it compounds once a year, this is a stupid question. How many times does it compound in a year? Once. So your n value is just 1. So you have r divided by 1, and you have 1 times t. So it becomes 1 plus r divided by 1, which is just r, and then 1 times t, which is just t. You see how they're the exact same? But this equation right here, typically, sometimes things can be like compounded quarterly. So how many quarters would happen in a year? 4. So then n is 4. And so you have 4 times t. Sometimes they compound monthly. How many months are in a year? 12. So n is 12. And then you have, it compounds 12 times every year, 12 times t, right? Or maybe it's weekly? So 52 and 52. What if it's daily? 365, 365. What if it's continuously? PE to the RT, that's continuous. Does that make sense? Y'all understand that? Yeah. Okay, those are the two equations though. You have this equation and you have this equation. So let's start looking at some examples. I'm also going to show you guys, I didn't have the initial intention. Actually, I'm going to start on the back side of this page. I didn't have the initial intention to show you guys how to use logarithms today to solve exponential functions, but I guess I will. Right now, though, the first focus as we go all the way down this thing is to really just show you how to set up the equation. And then I'll show you how to solve them. So let's read these and understand what it's asking. It says, you deposit $500 in an account that pays 4% annual interest. And the question for A, B, C, all of them, is going to be just how long, right? We're solving for T. How long does it take the balance to reach the following amounts? So how long does it take it to reach $1,000 when it's compounded quarterly? Y'all understand the question? So the question is, if I have $500, right? 1 plus my rate is 4%, at 4%, but it's compounded quarterly, right? Which is 4 times. So I'm going to take that rate, and for each time I compound, I don't get a full 4%, I get a fourth of 4% because it's going to compound 4 times, right? Then also raised to the 4t. So how long does it take $500 at that interest rate compounded quarterly, right, to turn into $1,000, to equal $1,000? How long does it take that $500, right? How much time? And you see how the time is in the exponent? You guys don't know how to solve that yet. I haven't showed you how to do logs, but that's the only way to solve these. When you're solving for a variable that's in the exponent area, you have to use logarithms. And you don't know how to do that yet. So we'll just leave it at that. Does that make sense, the setup though? Okay. What about how long does it take that $500 to reach $1,500 when the interest is compounded yearly? How many years happen in a year? 1. So that's a 1, okay? So notice now we have $1,500. How long does it take the 500 to turn into 1,500 when it goes through an interest rate of 1 plus 0.04 divided by 1 times 1 times t? And notice, guys, do you see how this is not actually the equation that we're using? Let's go back here. Oops, that's not. Okay. The equation that we're using is f equals p times 1 plus r to the t now. You see what happens when we don't have any compounding interest? It just ends up being divided by 1 and times 1. So it doesn't change, right? So you don't need to put it. Exactly. So I'm just telling you, instead of memorizing 2 separate equations, understand that when you just have compounded interest, you take the interest rate and divide it by however many compoundings are happening in a year, right? And then you also multiply the number of compoundings times however many years. Okay, it's the same equation. All right. Any questions on this one? Okay. So, this one. When is it going to be $2,000? If it's $500 originally compounded, what? Continuously. What's the letter? What's the P-E? P-E to the R-T. What's my rate? 0.04. Okay? Now again, notice all of these can't be solved unless you use logs, right? You need to use logs in order to solve this, anything up in the exponent. If you're solving for a variable that's in the exponent, you have to use logs. Okay. Any questions on setting these up though? Pretty straightforward stuff? Okay. On to the next one. A car is originally priced at $35,000 and it loses 5% of its value each year. Write an exponential decay model. Okay, so the future value of the car is equal to how much does it cost now? How much is it worth now? $35,000. Times 1. Now, is it increasing or decreasing value? Decreasing. So am I subtracting or adding to it the 5%? Okay. And do you see anything about compoundings here? Like, do you see any n value? So I don't need to divide by n. I also don't need to raise it to the n times t. Just simply to the t power. So when you have compoundings, you're dealing with the n. If there are no compoundings, then you're just dealing with a regular exponential growth or decay. If it's continuously, then it's not neither. It's PE to the RT. All right? It really is as simple as that. Okay. Let's keep going with this. What is the value of the car in 3.7 years? This is a great question. Can we solve this? Yeah, because now we're not dealing with solving for something that's in the exponent, right? We're given the exponent. The exponent is going to be 3.7. So the question is now, what's the future value if the car starts at $35,000? It's, hold on, I'm going to make a jump real quick, right? It's only worth 95% of its original value every year. Do y'all see why I just did 1 minus 0.05? That is just 95%. You can look at that two different ways. It's the same thing though, okay? Any questions on that? And then to the 3.7? And we can answer that. So I see some people typing it in already, so I'll just wait and somebody tell me when you get it. 28,900 what? And 80 cents. So after 3.7 years, that $35,000 truck is worth $28,949.80. Okay? As it decreases value of how much a year? 5%, right? 5%. I'm just going to ask another question. How much value does the truck hold every single year as it gets older, 1 year after the other? 95% of the previous year's value, right? And that's what this is. Does that make sense? You're taking the original value, multiplying by 95. Now it's only 95% of that value, right? Times, now it's only 95% of that value. Times, now it's only 95. Do you see how it's just decreasing by 95% every year? 3.7 times. Okay. How long will it take it to depreciate to a value of 23,500? So again, this is a how long question, so we're solving for t. And we can't do that without logarithms. Okay, so this is how long will it take $35,000 truck to turn into 23,500? How long? When it's maintaining 95% of its value every year. How many years? How many years will that take? Do y'all understand those? Okay. Any questions on the setting up part? So let me explain the solving part now with logarithms. I'm going to tell you what logarithms do. Okay. Now let me actually begin that by introducing, if I have 5x equals 10, how do I solve this? This is 5 times x. How do I get rid of 5 times x? You divide. So there's something that undoes multiplication, which is division. You divide, so you end up with x equals 2, right? How do I get rid of something like the square root of x equals 7? How do I get rid of that? Square. Right? To get rid of a square root, if I want to solve for x, I have to square. So the square, like when I square something, that's the inverse operation of taking the square root. And what I do to one side, I have to do to the other side, right? So x equals 49. Y'all good with that? Okay, so if I need to solve for a variable that's in the exponent, right, I need to take the log, and the log is going to undo that exponent. Okay, so if I square something, I need to take the square root. Square rooting is going to undo the square, right? If I multiply by something, I need to divide, because dividing is undoing the multiplication, right? If I have an exponent that I need to solve for, I need to take the log, because the log is going to undo that exponent. Y'all understand? Okay, so here's how I would do it. I would begin by realizing that this is 0.95 to the t power. So the t is on the 0.95. It's not on the 35,000. So I'm going to get rid of that 35,000. That's the first thing I'm going to do by dividing it. Right? 35,000 is being multiplied, so I'm going to just divide by 35,000 on this side and this side. What I do to one side, I have to do to the other. So those cancel, and I end up with, if I remember correctly, 47 over 70 equals 0.95 to the t. Everybody good with that still? Yeah? Okay. So now, I can't, this is the thing, guys. You might be tempted to divide by 0.95, but this is not 0.95 times t. This is 0.95 to the t power. This is where the logs come in, okay? So now all I've got is the 0.95 and the t power. But that 0.595 is the base. Y'all understand that? So check this out. Logs also have bases. Control log. You see that base? Okay, now if I do the log base of 0.95 of 0.95, think about what I just said. Logs undo each other. What do you think the log of 0.95, log base 0.95 of 0.95 is going to be? It's going to be 1. That log base 0.95 of 0.95 undoes it, and that's going to be 1. Okay? Just like 5x divided by 5, 5 divided by 5 is 1. Y'all understand? So log base 0.95 of 0.95 is 1. So what we're going to do now to get rid of that 0.95 and to move this down out of the exponential area is I'm going to say, oh, well, log base 0.95 of 0.95 to the t power, these are going to cancel, right? But whatever I do to one side, I got to do the other side. Just like if I multiply by one side, like if I divide by 5 on one side, I have to divide the other side by 5 also, right? So if I do the log base 0.95 of one side, I do log base 0.95 of 47 over 70 as well.
So it would be like 7.7.
Something like that. So look, guys, we already know log base 0.95 of 0.95 is just 1, so those are gone. So t equals whatever this is. So let's do it. Log base 0.95 of 47 divided by 70. 7.76608. Not that. 7.76608 years. Right? So the question was, how much time does it take $35,000 truck depreciating at a value of 0.5% or 5% every year, right? To depreciate to $23,500, it takes a little over 7.5 years, maybe about 8 years, right? 7.76608 years. Do y'all understand how the logs work? Let's do a few more. Now let's solve. Let's go back and solve all of these using these logs. So, let's do this one. This is a great one. Actually, let's do this one last. We'll do this one last. So that's going to be last. Let's solve these other ones. So first thing I would do if I'm going to solve for that t up there, here is do what? Get rid of that 500. I divide the 500 off. Okay? So actually, let me get on another page. I feel like I'm kind of running low on space. So we'll do this. Okay. So yeah, pretty much. It's like you just highlight it. You ever use the snipping tool on your computer?
No.
It's the same thing.
Swivl.
Okay, so divide by 500. So 2 equals, now guys, instead of writing 1 plus 0.04 divided by 4, I'm just going to write that as a single number. It's a lot easier to work with. So like, for example, what's 0.04 divided by 4? 0.01, right? So what's 1 plus 0.01? 1.01 to the 4t. Y'all got that? Okay, now I pretty much have done everything I can do. I can't divide by 1.01 because this is not 1.01 times 4t. This is 1.01 to the 4th t power, right? This is where I need to use logs. So I do log base what?
4.
This is my base right here. So what's the base of my log?
101.
1.01. So I'm going to do log base 1.01 of 1.01, right? So that those cancel.
But you have to do it to the other side.
You have to do it to the other side. So 4t equals log base 1.01 of 2, right? And these cancel. So 69?
69.6607.
6607 equals 4t. Now, this is a great example. Notice the 4 didn't come down, the t didn't come down, the 4 and the t came down, right? So I haven't solved for t yet. Just give me a second. Hello? Yes. Sure. need to go to this breaks. Okay, so we've solved for 4t. So what's the last thing I need to do? You guys should know this one. Just divide by 4 now. Now that you've got it out of the exponent, just divide by 4.
17.4.
17.4 equals time. Time equals 17.4. Do you guys understand? Like the use of a log to pull the exponents down so you can actually work with them? Okay, that's the idea.
So
now, yeah.
That would be 17.4 quarters.
17.4 years. T is just years. It's not in quarters. It's just years. Okay. So let's do last one right here. This is really good. Have you heard of ln or natural log? ln? No? Okay. Let me explain what it is. We're gonna get there pretty soon here. When I solve this, what's the first thing I would do here? Divide by 500. So I'd end up having 4 equals e to the 0.04t. Everybody good with that?
Yeah.
Okay. What's the base?
E.
E. 2.718, right? Whatever it is. So I need to do log base e to both sides. Y'all understand that? Okay. So if I have 4 equals e to the 0.04t, in order to get that down so I can start working with it, I need to do log base e. Log base e of 4 equals, and instead of writing this, what's log base e of e? It's going to be 1. So that equals 0.04t. Is everybody okay with that?
Yeah.
So
Okay.
you just type E like on the
Yeah, so let me show you. Watch. Log
you
Oops.
didn't press control.
log base, the e is under this pi symbol right here.
Oh, okay.
I'm guessing it's like an irrational number sort of button, or special number sort of button. Log base e of, what was it?
4.
Just 4?
Okay.
Okay, log base e of 4 is that. Now here's something else that's interesting, guys. Let's see if you can connect the dots. Here's natural log of 4. You ready? It's the same thing. So what's natural log? See if you can connect the dots. Natural log is log base e, right? Because e is the natural continuous growing number, right? So it's called a natural log. So if you have log base e, all you need to do is take the natural log. Obviously, you can type in log base e if you wanted. It's the same thing. But natural log is log base e, okay? Do y'all wonder? I wondered this for a long time. I don't know the exact answer, but I think, why is it ln versus nl? If it's a natural log?
Well, natural.
Yeah. No, it really is as simple as that, though. I mean, like, it wasn't English people that came up with the mathematics on all this stuff, right? Most of it was Greek or Arabic, you know.
Or Pascal.
So if it's Latin-based, then instead of like saying brown dog, they say dog brown. You know? So it's just log natural, the natural log. Okay, so with that being said, that should be enough for you guys to do pretty well on the front side of this. Okay, so you should be able to do most of this. Here's something that you're familiar with. Guys, this right here is just F equals P times 1 plus R to the T. That's all that is. Okay? Did that turn off? Nope. Well.